Welcome everybody. Let me first introduce myself. My name is Marcel Offermans. I am the Managing Director of Studio 397, which is part of the Luminis company. And I have a background in mechanical engineering, but at a young age, I was always interested in software development. So naturally, once I graduated, I ended up programming, having a lot of fun doing that. And basically, I've been part of Luminis ever since the start of the company. Currently also a fellow at Luminis, and big reason why I'm here today, also a long-time sim racer. So we're going to talk about racing into the future, and I'm going to tell a little bit about rFactor 2, our racing simulation. And just to give you an overview of what we're going to talk about, I'm first going to give a little bit of a background on what is rFactor 2, what's his history, and how we came to where we actually are today. From then on, we're going to do a deep dive into the architecture in general of racing simulations and of rFactor 2, particularly. We are, after all, at a DevCon, so we want to talk about code, talk about development, and how all of this is structured. But a simulation is nothing without content, so I'll not just talk about code and how to do that, but also about how to develop content, how to build cars, how to build tracks for it, and everything you need to do to make that happen. From that moment on, we'll look a little bit at some of the cloud infrastructure that we're currently building to facilitate competitions, to facilitate esports. And as a last step, we'll look at esports, what we have been doing in the last year and a half in esports, and what our future plans are. So let's start with a little bit of history. Let's go back to the very first origins of the code base that has now become rFactor 2. And for that, we actually have to go back to the last century, to a game called Sports Car GT. You can probably still find it on the internet. It will not run anymore. It was built for DirectX 6 and Windows 95 or something like that. But it was actually the first commercial release of the simulation code base. This was a game, it was all about GT cars, and you actually started in a low class, building a career, racing track after track, getting access to quicker, faster cars, and that's how you sort of went through this game. There was a bit of online, but it wasn't really big at the time. And for the time, this engine already had a few things that were interesting. There was a day and night cycle, so you had night races, and it also actually incorporated rain, which made everything a lot more exciting to drive. So this is how the code base got started, and at this point, this game was developed by a company called ImageSpace Incorporated. It was published by EA, and they sort of got hold of this code base because at the time EA bought Westwood, whom you might know from some Command & Conquer games. That's actually why they bought Westwood, but they also got this racing game, published it, and then thought, well, there's a lot more we can do with this code base if we get a few popular licenses for it. So they went out and got Formula 1 license for a couple of years. They also got NASCAR, which is the other big series in the US, driving on ovals. These games were all based on Sports Car GT, evolved over time. And well, as you can see, they did a little bit more than half a dozen of them. And the interesting thing was that all of these games had some ability for end users to change them. A lot of the things you could actually tweak in terms of cars, in terms of tracks, was sort of encoded in text files. And even though there was no formal documentation for any of that, people soon figured out, oh, this is stuff that I can actually change, and it influences gameplay. And that's interesting because that sort of started a whole community around these games. And pretty soon they were not just about Formula One or NASCAR, but people were adding all kinds of content to them, building their own cars, building their own tracks. And even if you search the internet today, you'll still find lots of tracks, lots of cars that you can download. Now, officially this all wasn't allowed, of course. It wasn't endorsed, but it was possible. And ImageSpace did this for, well, a couple of years, as you can see from the years on the different products. And at some time they thought, okay, well, now we've done enough of these. We kind of want to build our own game. We see that this modding community that's there on the internet is kind of interesting. So what if we start building a game ourselves that doesn't officially license anything, but is sort of an open platform where people can add their own stuff. EA didn't really want that, so in the end they split up, and ISI decided, okay, we're just going to publish this ourselves on the internet. And they called that game rFactor, or as I'll refer to it in the rest of the talk, rFactor 1, to distinguish it from the other one. Now this was an interesting game because right from the start it was designed to be modified. And not only was everything encoded in text files, but there was actual tooling available and documentation for people to figure out how to do this. And being a fairly small studio, that was a smart move because that way they could get away with releasing a game that had no officially licensed content. And in case you don't know, licensing content costs money, a lot of money. If you look at the Formula One license right now, that's owned by Codemasters, you pay about 5 million a year for that. So that's a big sum of money, especially if you're a small company. You'd rather spend that on game development. So they released rFactor. They released some fantasy cars, some fantasy tracks, and basically just let the community add stuff. It took a little while for that to sort of take on, as people needed to figure out how all of this stuff worked. But within a couple of years, there was a huge community, lots of cars, lots of tracks, and it's probably still the largest database of content out there right now. Like its predecessors, it had a full day-night cycle. For some reason, they left out the rain, probably due to time constraints and making it work really well. And another thing that's interesting is that this code base suddenly got licensed by a lot of other game developers. We've got titles like Need for Speed Shift, Race 07, GTR, GTR2, Automobilista, and I probably forgot one or two more, Project Cars. You might have heard of those titles. They all were built on this rFactor engine. And they became pretty popular games, some of them even bigger than rFactor itself. Another interesting thing is that, well, in the keynote you saw a little bit about Rudy and his new job at McLaren in the simulator. Actually, a fork of rFactor, now called rFactor Pro, is used by many of the Formula One teams for their big simulators. Of course, there's many things that are really different compared to the code that you can run on your own machine, such as that they run it on a whole cluster of machines, that they have way more accurate track data. They actually laser scan everything and have a point cloud that they drive on. They add their own algorithms because they have car simulation algorithms that they're not willing to share with anybody else. So the code base allows you to take parts of the existing simulation out, replace them with new stuff, and that way you sort of build your own custom simulator. And yeah, this is also still done on the same code base, obviously with many extensions. But the interesting thing is, I mean, this is a fork that's used by the big teams, Formula One, NASCAR, etc. They have millions to spend on a good simulator. There are a lot of other racing teams and racing classes that don't actually have millions. And a lot of them actually use rFactor or rFactor 2 as the basis for their simulator. And they built something around that that's a little bit similar to one of the simulators that we actually brought here. So you can have a try at that yourself. And that's actually very valuable to these teams. So you don't need to spend millions to get value out of simulation for driver training, for developing your car, etc. So a lot of talk about the history. Now let's get to the actual game rFactor 2. It's still an evolution of the same code base, and compared to rFactor, there's a couple of things that have been greatly improved or replaced. First thing, and probably for simulation the most important thing, is that it has a physics model that's a lot more advanced, both in terms of the actual car physics and suspension modeling, car engine modeling, turbo, stuff like that. We even have electric engines, which we use for our Formula E car, but also the tire model. And the tire model is a complete new development in rFactor 2, and it's actually based on a physical model of a tire. I'll get into that a little bit later when we talk about building a car. But that allows us to create tires that actually wear, that can have flat spots and everything. Yeah, they're quite high-tech and probably the best we can get to at this point in time, given the speed of computers, because that's in the end what's holding us back from taking next steps. Another thing is that we have live weather. Not only can you sort of pre-program the weather, but you can also literally hook it up to a weather station and get live weather during a race, which is very exciting because then nobody knows what the weather's going to do. So that gives you some interesting strategies, and you actually see teams looking at these weather forecasts and trying to predict exactly when it will rain or when it will stop raining. So that's really nice. And we've built a sort of track model that's dynamic. Dynamic in the sense that whenever a tire of a car drives over a piece of track, it will drop a little bit of rubber, and that will be more in turns than on the straights, or more when you accelerate compared to when you're not. It depends on the compound of the tire, etc. But you get rubber buildup, and we actually measure that and keep track of it throughout the whole track. And we synchronize that in case of multiplayer. So we make sure that everybody on the network has the same state of the track. And it's not just rubber buildup, it's also marbles, which are these little pieces of rubber that fall off a tire when it gets used. So you usually see those in the outsides of turns. It's usually not the best place to drive with your car because it's a little bit more slippery, and you get all kinds of dirt and stuff on your tires. You don't want that. And in case it's raining, we also measure water depth and make sure we know how wet each piece of the track is. When cars drive there, it dries up again. If the sun shines, it dries quicker. All of that stuff we take into account. So that's quite high tech. And the other thing we've improved the AI drivers. They actually do more in terms of blocking and racing you. So they are not pussies that will go away if you push them. We also did a little bit of extras on multiplayer and on driver swaps. So all of this talk about rFactor 2, image space, doesn't really explain how we got involved as Studio 397. And yeah, this is a story that sort of goes back a long time. My personal involvement in sim racing. And initially, It started out as me just playing games and combining that gameplay with some of the software development that I did. And one of the first things I actually wrote was an online matchmaker for a game that's long forgotten now, together with actually one of my colleagues who still works at Studio 397. And that's how we sort of got involved a little bit in, well, I wouldn't say professional, but hobbyist software development in sim racing. Over the years, I did more of those little projects, and all of a sudden I was approached by ISI to actually do projects for them. And one of the first and most interesting projects to date was porting rFactor and rFactor 2 to the Steam platform. And how many of you actually know Steam? Just interesting. Okay, so most of you play some games. It's a big app store, mainly for PC. And rFactor wasn't for sale on that, so I thought it would be interesting to take on that job. So I actually did that. And right at the time that that was finished, we got another phone call from Raiza Studios, a Brazilian company. They had actually licensed rFactor 1, and they wanted to build a new game out of it. But they discovered they had no software engineers with actual knowledge of the code base. So they approached us, and we helped them in about 9 months to build a game called Automobilista. And those of you who have been here in the DevCon 2 years ago might have remembered that talk. We explained a little bit about what we did there and how that worked. And right at the time that we were done with Automobilista, I got involved in some talks with ISI, who at the time were interested in developing the next project. And they are a relatively small company. I think they have about 5 software developers. So doing more than one thing at once wasn't really working for them. So their initial question was, would you like to be responsible for the maintenance of rFactor 2? I said, well, maintenance, that sounds boring. Probably most of you will agree with that. So I just said, well, maintenance, nope, but if you kind of give me the code base, I would like to run with it and see what I can do. I thought, they're never going to say yes to that. Naturally, they didn't immediately say yes, but they said, well, we can talk about that. We did that for a couple of months and actually made a deal with them to take over the code base and start developing it ourselves. And well, as a long-time sim racer, I thought, well, there's a lot of life left in this product. And if you just look at its history, that's sort of a testament to the fact that it's probably good, otherwise it wouldn't have been around for so long. So we had all kinds of ideas that we wanted to explore there. So about a year and a half ago, we could finally publicly announce that we actually did take over. And from that moment on, yeah, we started adding new things to it. Been talking a lot about rFactor 2, so maybe this is a good moment to take a look at what rFactor 2 actually is, what it looks like. And I didn't want to miss the opportunity to actually do that in a big movie theater. We made a nice trailer, so let's watch it together. Let's hope it works. Well, it's a little bit of a commercial, but I hope you'll forgive me for that. So that concludes the introduction of what rFactor 2 is, how we got involved. So let's look at the actual architecture of this simulation. And well, I'm sure there's a few architects in this room. I've already spotted a few. And those will be familiar, I think, with the 4+1 architectural view. And even if you're not familiar with it, I'll explain how it works anyway. Roughly, it's a view where you take 4 different perspectives of a system to explain how it works at a high level. And there's actually the +1, the 5th perspective, which is the use case view in the center, arguably the most important one, because usually we make software for users. So that's sort of a central view on the system. And in this view, we describe these different perspectives one by one to sort of build a whole overview of the actual system. And I'll explain the views one by one as we go over them. In this case, the use case view for a racing simulation is pretty easy, because all you really want to do is drive. So that's the main use case. There's a little bit of configuration you usually want to do, some technical stuff such as setting up your system, some stuff that you want to do to the car, such as setting up springs and dampers and wings and stuff. But in the end, that's all things that you are not that interested in, you want to drive. So it's a really simple use case. And as we'll also be talking later about building competitions and cloud infrastructure, there's sort of a secondary use case. And I've summarized all of that with the sort of administrator that has to have some features to actually build a competition, set it up, maintain all the servers, etc. Second view we'll look at is the logical view. And this still is a very user-centric view where we decompose the system into functional components that are really close to the user. And in this case, I've chosen to actually decompose it in terms of the different screens that we have in the game. And at a high level, if you look at the view at the top, we have again the driver as the main actor here, and there are 3 different states in which this game can be. You have the main menu where you set everything up. Once you've set everything up, you end up in the sort of session menu. That's the second part, and that's where you also jump in the car and start driving again. So that's the last screen. So main menu does everything like track selection, car selection. You have a lot of session settings. You can say how long a session should take, what the weather conditions are. And there's also a lot of other options that you can configure, such as graphics, audio options, configure your controllers. We work with a very wide range of devices, so you need to set those up. And then either you drive offline or you go online, which can be done either through a matchmaker, where you look at a list of servers and decide, okay, this sounds like a fun race, I'm just gonna jump in and join these guys. Or you can take a slightly more structural approach and say, okay, I want to join some competition, so I'm gonna sign up for that. and then it will notify you every time there's a new race and a new session going on for that competition. And we'll get to that a little bit later. Once you're in an actual session, there's two big screens. One is the monitor, which allows you to look at lap times of yourself, of others, to actually look at different camera angles around the track. And another, arguably the most important part of the user interface, is the actual garage, where you can set up your car. And depending on the car, we have up to a couple of hundred options that you can actually configure. So there's a lot of things you could be doing to the car. Usually when you start out, we advise you not to mess with the car too much. First learn to drive, be consistent, and then start making small changes. And obviously in car, well, you're just sitting in first person view, looking around and trying to drive the car, keep it on the track, and hopefully be the fastest. Again, second part of the logical view is sort of the admin view, and I just already spoke a little bit about it. I'll get back to that when we get to the competition. So let's move on to the next view. And this is a very straightforward one, the physical view, where you describe the physical components that make up your system. So in this view, what we have is very simple. We have clients, just the PCs that people have at home. They're using that to drive. They all connect either to a game server, or when you're racing offline, you don't connect to anything. It's just your machine. And those game servers might or might not be connected to a competition server, depending on whether they participate in that or not. So those are the physical components that make up this system. Then, when we're talking about real-time simulation, we have the process view, and that's probably one of the more interesting views to look at, because simulation and real-time simulation especially, it's really important to actually manage the processes that you have running and to come up with a good design for that. And if you look at our system from a high level, there's two processes involved. One is the physics process, and the other is the graphics process. And both have completely different characteristics. For physics, it's important that no matter what system you have, that they always run exactly the same way. It wouldn't be much fun if by buying a faster PC, you got a better car or a worse car. It has to be the same. So our physics thread basically runs at a fixed rate. And that fixed rate for the body and suspension and everything is 400 Hertz. And our tires actually run at 6 times that rate. They run at 2400 Hertz. So that's not a lot of time you have to do all your calculations if you count that back. That's less than a millisecond. So we have to be really efficient there. And we have to make sure that we always finish our calculations within this 1/400th of a second. Otherwise, we're still in trouble. So we actually managed to do that. We have a quite extensive model of the car body and suspension. We're getting a bit technical here, but it's a rigid body model, and we have 85 degrees of freedom. So everybody who still knows their linear algebra and matrix calculations knows that's quite a big system to solve. So we have highly optimized code that actually does that. So that's physics. On the other hand, we have graphics. And graphics we can run as fast as possible, because from the physics side, we already made sure that every system behaves the same way. So for graphics, it's just faster your system, the higher the frame rate, and we'll just run it as fast as we can, unless the user says, well, my monitor is not going to refresh faster than 60 Hertz, so no need to calculate more frames. And yeah, this is really all about frame time. You want the frame time to be as low as possible, and you also want it to be consistent, because driving a car and having 60 frames in one turn and only 30 in the next, that also doesn't really work. And that's harder to manage because that also means we need to take into account how we build our content so we actually get a consistent frame time. And in the game we can render to a single screen. That's the most common use case. We have VR support, which means you effectively render 2 screens. And we have also support for triple screens, or in more fancy setups that becomes triple projectors, so you can actually have a 180-degree view of everything around you. And last but not least, the development view that we have. That's how we as software developers actually look at this code. And there we have 2 big projects. The actual simulation itself, which is predominantly a C++ code base. Java wasn't even, well, it was sort of around in '99, but it wasn't used for anything near real time. And that's still kind of exceptional, I think. In any case, all of that stuff runs in C++. And recently we've been adding a few new things to that code base and introducing new technologies. So some of that becomes TypeScript with a backend in Java, and certainly the whole competition infrastructure that we built, that's all Java-based backend and TypeScript as front end. And I think most of you know TypeScript is just a layer on top of JavaScript to make it look a little bit more sensible. People might disagree, but so a year and a half ago when we got the code base, biggest thing everybody, including me, was saying that graphics engine is really crappy. It was still a DirectX 9 engine. Well, it had a long evolution, but when rFactor 2 was released around 2012, 2013, DirectX 11 was already around. They just never got to upgrading the graphics engine. So when we took over, first thing we did was, okay, let's try to build a new graphics engine, not just because we have more features and can make a better looking engine that way, but DirectX 11 was also sort of the lowest version of the API that you could use if you were interested in VR support. And that was also something that a lot of our users were asking about. So we went and basically put a layer between the actual graphics implementation and the rest of the code, because initially we wanted to make sure that we could run both engines, so DirectX 9 and 11, side by side. And we wanted to make sure that they actually rendered all the existing content out there, because that was also an important thing for us. There's a huge library of content. You don't want to throw all of that away by just making a new graphics engine. Community in general doesn't really like that very much. So it had to be compatible, and for a while, actually until the beginning of this year, we ran both of them side by side. And you could actually choose as a user which one you wanted to use. Right now we've completely switched, so it's DirectX 11 only. And on top of that, we've also added a lot of new features to make it look better. Because we're sensible, we didn't build all those features ourselves. We actually used a post-processing library for a lot of these effects, things like depth of field, bloom, lens flares, all that kind of stuff. And the library we chose for that is a product called Yebis, and that's being used by a lot of other graphics engines as well. We already had some experience with it when we started, so that was a natural choice to go for. The other thing that needed replacement, and that's something we're actually still working on at the moment, is the user interface. The original user interface of rFactor 2 was a custom designed toolkit written in C++ just for this game. If you wanted a button, you needed to implement a full C++ class with lots of stuff. If you wanted that button to appear on a screen, you had this I don't know, probably 100,000 line big text file, which listed all the screens and all the elements on those screens. There was no real editor for any of that. So it was just you and your favorite text editor. And making any kind of significant change to such a UI was painful. So we said, okay, we have to bite the bullet, throw all of that away, and make a new user interface. And well, if you then start talking about what kind of technology should we be using for that, I think it's a pretty sensible choice to go for HTML. Especially if you're on open simulation, you want user involvement, maybe also in some parts of the user interface. So that was quickly chosen. That meant we actually had to embed a browser in the system. Well, those are available as well as components. Chromium Embedded Framework is what we used. So we used that. That runs as a separate process within the game. It talks to a web-based backend, which we built in Java because we have lots of tools there to build those backends. We actually embedded the Java virtual machine into the game engine, and it's directly talking through the Java native interface to the existing parts of the C++ code base. And that worked all really well, except for one thing. The original code base wasn't really designed to be thread safe. It was just a single graphics thread, and the UI would actually be redrawn at each frame. And yeah, nothing was thread safe there. And all of a sudden we had our nice browser with our different worker threads hitting this native code, and well, that blew up pretty quickly. So biggest change we needed to make there was to make sure that we would properly interface between this highly multi-threaded world and a non-thread safe graphics thread. And well, it's not even that weird of a problem to have. There's lots of other toolkits that have similar constraints. So all we really needed to do was have a sort of command pattern in between with a queue. So all the worker threads trying to execute commands would put those commands on a queue, and the actual graphics thread would pull that queue, and it's running and pulling at 60 or 90 frames per second anyway. So it's just pulling those commands and actually executing them on the graphics thread. So we have the native code and the native thread just executing directly those Java commands, but on the right thread. And that nicely solved our problem. And yeah, we're actually pretty far along. We have some screens here on the right built with that new interface. And we're reasonably close to releasing that to the public. As I said, it's not just about code, it's also about content. So let me briefly go over the process involved in developing that content as well. And let's start by building different tracks. Sort of the first thing when you have to build content is the actual boring part, which is license negotiation. Because you can't just build a track and name it Spa or Sebring or whatever. You actually need a license from the actual track to be able to do that. And they're willing to give that to you, but you have to pay. And well, there's a bit of negotiation there because they usually start pretty high. We want to be a bit lower, etc. It also takes a lot of time. It's not uncommon for this process to last between 3 to even 6 months in some cases. And we have some exceptions where we've been talking for more than a year now and still haven't reached an agreement. But once that's out of the way, there's a couple of steps we take. The first part is actually surveying the track, and part of that is simple. You just take a good camera, start taking pictures, both of everything around the track, the actual track surface, other textures that you later need in the game. Just take lots of pictures. The other part is trying to figure out the exact model for the track. And sometimes you get CAD data from the actual construction of the track. If it's an old track, that's usually not there. So another popular way of getting a really accurate model is by laser scanning it. And that's nowadays usually done by having a truck that drives really slowly with a portable laser on top. It just drives around the track, laser scans basically every square centimeter of the track. So you get lots of points in the big point cloud. You actually also get the color of the pixel at that point. So that's a huge amount of data. Great because it's super accurate. Not that great because it's terabytes in size. Not really what you want, not suitable for the game. So there's actually a whole conversion process beyond that. And that process we sort of approach in two phases. The first is the actual modeling of the track. And on this image you see Sebring, which is a track we just laser scanned. And we're building the track model here. And you see from the little squares that we have quite a lot of detail we can apply to each piece of the road. And in this phase we build the road and basically everything up to the barriers of the track, whatever those are. It's important for us to first build that and to make sure we get that absolutely right before we start adding all the stuff around that. I already explained a little bit about how our road is dynamic. There's a few other things. We can have different material properties basically for each little square you see here. And those material properties include stuff like roughness, which can make even a flat surface a little bit bumpy. And we can add stuff like decals for example, painted lines on the track. And since those painted lines are not infinitely thin, at least not in real life, we actually can give them a thickness in the simulation. And on some tracks, you can actually feel that if you drive over the painted lines. You feel slight bumps as you go over them. For stuff like grass, we also have a property that allows wheels to sink in to that material a little bit. So if you drive in the grass with two wheels, you'll actually feel the car sinking into the grass a bit, and you get all those different properties of that as well. Last part is probably what takes us the longest, and it's building all the trackside objects. Would be a lot easier if all tracks were just in the middle of the desert, but usually they're not. So there's lots of stuff going on behind those barriers. And because there's so much, we also need to use special game modeling techniques to build those 3D models. And that involves modeling things with as little polygons as we can, because that way we can have a lot of objects. But we still want to make those things look great. And textures and shaders are techniques that we use to actually make those things appear a lot more complex. And I've shown a couple of examples of that in this slide. The models are really low polygon, but by applying textures and textures that sort of change the way such a surface looks, you can sort of add details to them. You have normal maps which actually fake that there's some kind of bumps and cracks and things in the surfaces. And there's ambient occlusion, which makes sort of occluded parts look a little bit darker. And all of those things help in creating believable models. So once all of that's done, there's a few technical things we need to do. We usually add a bit of sound, and we have to actually add a few racing lines for the AI to help them out in navigating the track and being as fast as they can. But that's basically it for building tracks. Same we can do for building a car. So it's again license negotiations. It's again 3D modeling. Creating audio samples, which is quite tricky because we can't isolate sounds on a car. They all appear at once. It's a bit tricky. And then there's building the actual physics and tire model. Now, tire models are tricky because nobody will actually tell you how they make their tire. If you go to a manufacturer of a tire, they are very secretive about how the tire is built. So our best bet, if we can get access to it, is to get an actual race tire, measure it, and basically demolish it. Just cut it in half, look at all the different layers that are in the tire, how they are composed, and we use that to actually build a simulated model of that same tire. And that model we run through a non-real-time simulation where we basically simulate all the different possible conditions for such a tire. And to give you an idea, on a fast game PC, that takes us about 24 hours of calculations for a single tire. Usually car has about 3 or 4 compounds. Front and rear tires are not always the same. So there's quite a lot of modeling going on. And this is really based on a physical model where we actually define all the layers of this tire and make sure that we get the exact same shape. And on the right you see us overlaying a tire we created onto a real car to see how close are we actually to that shape. And as you can see, we can get pretty close. And all that data ends up as a huge lookup table and is used in the real-time simulation to simulate that tire. And that's the only way we can run that part at 2400 Hertz. Otherwise, even normal PCs wouldn't be fast enough to do that. So that's a tire. And then there's the rest of the car. Since that's moving slightly slower compared to a spinning wheel, that's all done at 400 Hertz. And it's basically a system of rigid bodies. And if you look at the image on the left, you see sort of a conceptual model of how a car is built, how the different rigid bodies interact. And yeah, we are able to make things like suspension really accurately. We can have chassis flex, so especially older cars are not infinitely stiff, so front and rear, you can flex them a little bit. Well, just try driving your own car onto a curb with one wheel and see if it bends. It probably does, because that's more comfortable as well for you as a driver. And we actually, for building this part of the physics, we have a big spreadsheet. And when I say big, it's really big. It has like 30 different tabs, and they all don't even fit on your screen. There's lots of real data that we can feed into that. And all of that data, and here on the screen you see an example where we are modeling suspension geometry for a car, where we try to get accurate measurements of the actual positions of all the suspension parts, but also the weights of the individual parts, the weight of a tire, the weight of a rim. All of that goes into the model, and the output of that spreadsheet is again a long list of text files with all the data that goes into the simulation again. So building a physics model is basically a lot of data collection, because we usually don't know everything. A lot of guesstimates and estimates of how we think stuff works, and we can see a lot and get a lot of data from the internet nowadays, and that's how we build our car. So since we started 10 minutes early, I'm gonna go 10 minutes late, I'm gonna go a bit longer as well. Now that we've seen everything in terms of content and code development in rFactor 2, let's look at some of the new stuff we're working on. And the first thing we're doing is actually building a cloud infrastructure that allows us to run competitions. Let me first explain what we mean by competitions, so you have a bit of an idea what we're aiming for. We want to run competitions, more than one at the same time, and people can participate in those competitions. And as an example here, let's say we have a Benelux GT3 championship. Each competition consists of one or more events. Events are usually run at different tracks. So here we have Assen, Spa, Zolder and Zandvoort. You plan those events in time, and for each event we can then configure what sessions you actually have. So you might have 1 or 2 practice sessions on Thursday and Friday, qualification session on Saturday, and maybe on Sunday a sprint race and a feature race. So you plan out all those sessions in time, and at the end of all those sessions, when the whole event is run, you get some kind of points calculation. Because in the end, it's all about who is fastest, who is first. So every event has a point standings, and at the end of all the events, you have the final standings for the competition. This is the model we're building, and it's quite straightforward. You can do all kinds of special things with it. Just to give you an example, we're looking at having competitions where each event lasts for about a week. We're doing that because not everybody can race at the same time. So during the week, we have each day or a couple of times a day a race, and you can participate in just one of those races, and as long as you at least do that once a week, you get points for that week, for that event. And that way you can participate whenever you have time, assuming you have at least one evening or one time a week where you can show up and still be part of that competition. We can obviously also do all kinds of specials based on this, but this is the sort of end user architecture, end user view. Now let's look at the insides of this. How are we building this? And if you know us, Luminis, a little bit better, you might be aware that we have quite a few building blocks, quite a few components that help us build cloud-based applications. And we're actually reusing all of those within the solution we're building, because it saves us lots of time. We're building on Cloud RTI to be able to run on any cloud, public cloud we want. We're using Information Grid because running competitions is all about gathering a lot of data about each event, about each car, about each driver, and we want to hold on to that data and manipulate it in ways that we probably haven't figured out yet. So we need a system that's quite flexible in terms of how we can deal with that data, how we can change the schema for that data, how we can search through it, etc. And that's what this infrastructure gives us. On top of that, we build our competition infrastructure. And on the right, you see a little bit of the dashboard that we have running. And what you see during a typical hot lap competition, this was actually during World's Fastest Gamer, where on the back end we can see how many game servers we have running, who is logging in, who is generating faster laps, etc., etc. So we have a good overview of what's happening. Something goes down, we can replace it easily. So it's a pretty flexible system. We're in the middle of building this. We'll probably be releasing it somewhere later this year and keep adding to it in the years to come. So why are we doing this? Well, because racing is all about competition, and competition is all about esports, even though, well, you could say esports is just a fashion term. We were running online competitions long before the term esports even existed. But in the last year, and some of you might have seen that on the keynote already, we've been involved in some pretty cool events. We've run the $1 million Formula E Vegas event, where we provided the software for that. More recently, they also allowed us to build the latest Formula E car, so the one they're using this season. We built the first track that they're running on Hong Kong, and did a hot lap competition based on that in the days before the actual season opener was run, which is interesting because usually games don't get access to new cars, to new tracks before the actual events are run. So that was quite interesting. Yeah, we also run World's Fastest Gamer, which for us was a great competition. About 2,500 people participated as drivers in the qualifying rounds on rFactor 2. I don't know how many laps they ran, but It was a lot. And our live streams of this event were getting over 500,000 views, which is not bad at all for a simple game. So that's quite exciting. And I mean, in general, you see esports on the rise. Sim racing is still a bit of a niche. There are other games that are way more popular. But I want to actually make a case for sim racing as an esport. I think it's the perfect esport, and maybe you can find some other examples, but there are not that many. First of all, we mimic a real sport, which is good. There's even some discussions within the Olympic Committee about making esports into something Olympic, but they're not really fond of all those popular esports where people are just killing themselves. They are looking for esports that are a bit less violent. So we stand a good chance there, I think. And another thing that we have going for ourselves is that we come really close to the real thing. If you, for example, compare us to a game like FIFA, the skills that you learn playing FIFA, where you're controlling basically a whole team or one player at a time with your game controller, skills that you build for that don't really transfer to the real game. There's probably nobody considering hiring the top FIFA player to play in the Champions League final. But for racing, for sim racing, those skills do transfer. And well, we've got one great example here today, Rudy, but there are many other examples of drivers who started out sim racing, got into a real car, and I'm not saying they're competitive right away, because there are some differences and they do need to adjust to that. But they know a lot of the basics and they have a lot of driving experience, and that really transfers quite well. So I hope this grows as a sport. Wrapping it up, as I'm close to the end of my time, we've looked at rFactor 2, some of its history. We've seen it has a code base with a long history. That sometimes gives us technical challenges as developers. For me, a challenge was going back to C++ after only doing Java for like 20 years or something. But it's also enjoyable because, well, I think we all like challenges, right? So that's why we're coding, we're trying to solve problems. And it is a real cool problem to work at, so I'm enjoying that a lot. I've showed a little bit about the stuff we're currently working on and working on towards the future. So I hope you have a little bit of a better understanding of what this is all about. I'm not sure if we actually have time for a question, but I should at least say vote on your way out, and thank you very much for your time.